Question 8. Two boats, A and B, move away from a buoy anchored at the middle of a river along the mutually perpendicular straight lines. The boat A along the river and the boat B across the river. Having moved off an equal distance from buoy, the boats returned. Find the ratio of times of motion of boats tau A upon tau B if velocity of each boat with respect to water is eta equals 1.2 times greater than the stream velocity. The question is explained in this figure. A buoy is anchored at the middle of the river. The river is flowing with some velocity and the velocity of boats A and B is 1.2 times greater than the stream velocity. Boat A travels along the river and boat B travels across the river. Let the velocity of stream is Vs, then the velocity of each boat will be eta Vs, and let the distance travelled by each boat is d. Now let's evaluate time taken by boat A. The boat A travels the half distance with velocity eta plus 1 Vs, which is the velocity in downstream, and the latter half of the distance with velocity eta minus 1 Vs, which is the velocity in upstream. So the time taken by boat A, tau A will be equal to d by 2 upon eta plus 1 Vs plus d by 2 upon eta minus 1 Vs. On simplification, we will get d by 2 Vs multiplied by 2 eta upon eta square minus 1. Now let's calculate the velocity of boat B. The resultant velocity of boat B can be calculated by evaluating the angle in which the boat A starts traveling or it projects itself. So the angle will be such that the sin theta value is 1 by eta and cos theta value will be square root of 1 minus sin square theta will be equal to square root of eta square minus 1 divided by eta. The resultant velocity of boat B then will be eta Vs component towards the direction in which the boat B travels. So this will be equal to eta Vs cos theta, and cos theta equals to square root of eta square minus 1 divided by eta. So we will get square root of eta square minus 1 multiplied by Vs. Velocity of travel will remain same while traveling away and towards the buoy. Time taken by boat B. Tau B will be equal to d upon square root of eta square minus 1 Vs. Now let's calculate the ratio which is required to obtain in the question. Tau A upon tau B will be equal to, the tau A value will be taken from here, d by 2 Vs multiplied by 2 eta divided by eta square minus 1, and tau B is d divided by square root of eta square minus 1 multiplied by Vs. So if we put these values, we will get the ratio as eta divided by square root of eta square minus 1. The value of eta is 1.2. If we put the value of eta as 1.2, we will get 1.2 divided by square root of 1.44 minus 1, and on simplification we will get the ratio as 1.8. Thank you for watching this video.